Welcome back. In the previous video, I gave the definition of oxidation and how you can identify a reaction with oxidation has taken place, and also how you can identify what a reducing agent is in a chemical reaction. So in this video, our focus shall be on reduction and identification of oxidizing agents. Now, reduction is just the opposite of oxidation, as you will see in this video. Now, the first definition, reduction can be defined as the gain of electron. So in short, reduction is the gain of electron. So for example, as I will show you, I showed you in the previous video that for when ion 2 ion wants to form ion 3, it lost an electron for it to form ion 3 ion. For example, look at the reaction Fe2 plus this ion 2 ion. Now it lost an electron to form ion 3. We have Fe3 plus E minus. So if you discover that we have the same number of charge on both sides. The charge is balanced. So that's what happened. Now for ion 3 ion to form ion 2 ion back, it has to gain that electron back. Are you get what I'm saying? It has to gain an electron back. What am I saying in essence? Now this example I give, this is an example of oxidation. This oxidation. Now that's the loss of electrons. The electron is lost. Now for ion 3 ion to form ion 2 ion, so do you know what happens? It has to gain that electron back. Fe3 plus E negative. Then what you have is Fe2 plus. Is it balanced? When we have minus 1 here, minus 1 plus 3, that's plus 2. That's how we have Fe2 plus. How you got what I'm saying? We have Fe2 plus. So that's what it has. It gains electron. Can you see this gain? And look at the equation here. The electron is on this side. So that's for reduction reaction. But for an oxidation or reaction, the electron is usually on the right hand side. That's what you notice. So it gains that electron, it becomes Fe2 plus back. So reduction can be defined as the gain of electron. Are you getting it? So that's that. We won't waste time on that again. Now the reduction can be defined as the decrease in oxidation number. So now what do we mean as decrease in oxidation? Decrease in oxidation number. Now I will show you now. Look at here, for example. Look at chlorine here. I'm still using the same equation. The oxidation number of chlorine is 0. The oxidation number of chlorine is 0 here. Don't forget that any element, as I said in the rules for assigning oxidation number. So if you are still confused on what the video on rules for assigning oxidation number. Now look at here, is 0 here. So now boy here is, according to how I determine it in the previous video, it is minus 3 here. The oxidation of chlorine here is minus 3. Now between 0 and minus 3, which one is bigger? We will discover that 0 is actually larger than minus 3. So which means the oxidation number of chlorine has decreased from 0 to minus 3. So that's what you call reduction. That's the decrease in oxidation number. So for example, so this reaction now, what actually happens here can be described as reduction reaction. And you see now that they take place at the same time, reduction reaction. So this oxidation, reduction reaction. So now for the example again, addition of electropositive elements. That's oxidation. Addition of electropositive element. Any reaction with electropositive elements is added to a substance is an oxidation reaction. For example, now look here. It's a reduction reaction. Sorry. Now look here. Okay. I can still extend it to chlorine. Now look here. This chlorine. Sodium is added. Sodium is the electropositive element added to it. So which means reduction is actually taking place there. That's the addition of electropositive elements. So this reduction. I hope you understand my analogy. So this is the sodium. It was chlorine here, but at the other hand, it became sodium chloride. So which means sodium was actually added to chlorine. So that's electropositive element was added to chlorine. So that's what we have at the other end here. So that's why they call it addition of electropositive elements. So that's that. And removal of electronegative element. So when electronegative element is removed from a substance, so we can call it, so that's a reduction reaction. So now let's move forward. Also, addition of hydrogen to a substance. Addition of hydrogen to a substance. Now look at this reaction. Can you see? So now, if you discover that it was chlorine here, but hydrogen was added to it at the other end here. Hydrogen was added to it at the other end here. Now, addition of hydrogen is electropositive, so we can call, if we say addition of electropositive element, we are still right. Now, addition of hydrogen to a substance. Now look at it. It was chlorine here. Hydrogen was added. It became hydrochloric acid here. Hydrogen chloride here. So can you see? So this is an example of reduction reaction. This reduction. So now, what was an oxidizing agent? As I said in the previous video. Now look at it. Any reaction that any of these characteristics is being carried out is an oxidizing agent. For example, now any reaction in which there is gain of electron, such reaction is any substance that gains electron, that substance is actually an oxidizing agent. Is actually an oxidizing agent. For example, now let me see. Do you know what actually happens here for chlorine to form Cl minus 3? Now, for example, now look at it. Cl plus E negative actually becomes Cl negative. Are you getting it? Cl negative. Now, Cl negative plus E negative, that's Cl2 negative. Cl negative plus E negative again, that's Cl3 negative. So that's actually what happens here. That's why the charge here is minus 3. It actually gains 3 electron. Are you getting it? It actually gains 3 electron. So that's that. Can I do it in a single step? In a single step, Cl minus 3 Cl. Okay. So let's leave that. So that's what actually happens. So it actually, okay, that's the decrease in, what am I saying? Gain of electron. So it actually gains electron. Now when non-metallic elements, when they gain electron, they become negatively charged. So it actually gains electron. So to actually for it to become Cl minus 3 at the other end here. So the same thing goes to addition of electronic. So this is an oxidizing agent. Anyone that gains an electron is an oxidizing agent. That's what I'm establishing. So this decrease in oxidation number, anyone with the oxidation number decrease is the oxidizing agent. Look at here. The oxidation number of chlorine decrease from 0 to minus 3. So this is an oxidizing agent. So the same way, addition of electronegative elements, anyone in which electronegative element is added is an oxidizing. Electropositive element is added is an oxidizing agent. Look at here. This is our oxidizing agent because electropositive element is added to it. So the same way thing goes. Addition of hydrogen, anyone in which hydrogen is added is an oxidizing agent. Look here, chlorine here. This chlorine is standing alone on its own. So that's hydrogen is added to it. So this will be our oxidizing agent. So that's how you recognize them easily in a chemical reaction. So you can recognize both oxidizing and reducing agents in a chemical reaction. So that's the easy way to identify them. So we'll do further works on it. Thanks for watching the video. Don't forget to subscribe and share with others. See you later. Bye.